Hello, this video is about angles on the unit circle and the definition of trigonometric functions. My name is Hossein Lamir Ramandi and the intensity of this video is mild. Okay, let's start with the unit. We can measure angles in radians or in degrees. For example, pi radian is the same as 180 degrees. Pi half radian is the same as 90 degrees. This is the right angle. In general, to convert from degrees to radian, we multiply by pi over 180, and to convert from radians to degrees, we multiply by 180 over pi. Radian is closely related to the length of an arc. For instance, let's calculate theta in terms of r and l in this figure. Recall that the perimeter of a circle of radius r is 2 pi r. So in this figure we have that L over 2 pi r is equal to theta over 2 pi. From this we get that theta is equal to L over r in radians. So if r is equal to 1, theta is exactly the length L. Theta is exactly the length of the arc which is facing it. Okay, now let's work on the trigonometric functions on a right triangle. Sine, cosine, tan, cotan, secant, and cosecant are calculated the way it's shown in this slide. If the angle A as it is shown in this triangle. But we can calculate the trigonometric ratios of an angle when the angle is shown on the unit circle. For instance, if A is in the area 1 as shown in the circle, sine theta is the y-coordinate of A, cosine theta is the x-coordinate of A, tan theta is sine theta over cosine theta. As you see in the picture, the radius of the circle is 1. It's very important that if you want to use these formulas, the radius of the circle has to be 1, and the center of the circle has to be the origin. This is the unit circle. So if the angle is described in the unit circle, you can calculate the trigonometric ratios of this angle theta by the xy coordinates of the point. It doesn't matter if the point is not in the area 1, it can be in area 2, 3, or 4. As long as the radius is 1 and the center of the circle is origin, you can use these formulas for finding the trigonometric ratios. Okay, we can find the rest of the trigonometric ratios easily. I leave it as an exercise. The advantage of this way of calculating the trigonometric ratios over the triangle is that the angle can be larger than 90 degrees, or the angle can be negative. In order to see that, let's pick a direction on the unit circle. As you see here, in figure 1, the positive direction is shown, the negative direction is also shown. So if we start from the x-axis, if we start from points 1 and 0, and move as in figure 2 on the red line until we reach that point, which is cut by the red ray, that angle is going to be 5 pi over 6. If we move, let's work on figure 3. If we move a complete circle and then move until we reach 5 pi over 6, as you see in the purple path, then you reach the angle, which is 2 pi plus 5 pi over 6. As you see, the geometric interpretation of 5 pi over 6 is the same as 2 pi plus 5 pi over 6, but these are different angles. Okay, we can reach that red ray, which was in figure 2, which was 5 pi over 6. We can reach that point, as you see in figure 4 by the yellow path, but we can have a different number, which is negative 7 pi over 6. So in particular, we can have trigonometric ratios for negative numbers as well. So for instance, the sine function is defined on all of the real numbers, as you see in this figure. The cosine function is defined on all of real numbers as well. And the tan function is defined for every real number except for the odd integers of pi half. You can find the domain of other trigonometric functions as an exercise.